I want us to celebrate the triangle mid-segment theorem by looking at a few interesting puzzles. Let's check them out and enjoy them together. So, given the figure here, we are told that P is the midpoint of LM, Q is the midpoint of MN, and R is the midpoint of LN. So first of all, what does all that mean? So we know that P is the midpoint of LM. That means that if I were to mark this up, I'd see that this segment is congruent to that segment. And then I'm told that Q is the midpoint of MN. So Q is the midpoint of this segment. So this length will equal that length. They're congruent. And finally, R is the midpoint of LN. So this segment right here and this segment right here are congruent. And what are we told? What does the triangle mid-segment theorem say? It says that the segment joining the midpoints of two sides of a triangle is parallel to the third side, and its length is half of that side. So we see I've actually connected some of them in here. I'm given some extra information, and now I want to see if we can use this theorem to actually answer some questions. The first one is, what's the length of RQ? Do it like a game show. What's the length of RQ? Well, let's take a look. Where is RQ? Well, RQ is right here, and I see that that's the mid-segment that, in fact, is opposite the ML side of the triangle. So I know that this length will equal half of this length. So one thing I can do, since I know that this segment and this segment are equal because P is the midpoint here, I could actually take 4.5 and add it to 4.5 and get 9. I could take 9 and then take half of it to get this and see the answer is 4.5. Or I could just be a little clever and say, wait a minute, this is half of this, and this is half of this. So therefore, this must be, in fact, equal to 4.5. So I'm using the triangle mid-segment theorem, and I immediately see that the answer is RQ equals 4.5. Either by finding the entire length of this is 9 and taking half, or realizing this is already half of that length, which is equal to that length, because this is half of that. Bang! We're done. Now, here's another challenge for us to consider. Since you did that one so quickly, holy cow, I can't keep you down. I want you to find the measure of angle MPQ. Well, where is the angle MPQ? Well, MPQ. Ah, it's this little angle right in here you want me to study. Well, how in the world am I going to think about that? Well, I know that this angle, PQR, is 49 degrees. Now, what can I do with that fact? Well, I do know by the mid-segment theorem that, in fact, this line segment is parallel to this line segment. So I know that this line is parallel to that line. Check it out. I've got parallel lines. This PQ is acting like a transversal. And notice that these are alternate interior angles. And we know that alternate interior angles of parallel lines cut by a transversal will have the same measure. Those angles are congruent, which means if this is 49 degrees, then in fact this must be 49 degrees as well. And so this equals 49 degrees by the alternate interior angles theorem, because these are parallel, this is a transversal, this is 49 degrees, and this is the alternate interior angle to that. Bang. Couldn't be more easy. You can see the power of the triangle mid-segment theorem, and I hope that you will use that power only for good and not evil. I'll see you soon.